Alright, so I just wanted to go over how to do this with a calculator for finding a linear pattern. Now there's a couple of sources around for this as well, but I'll just go through it quickly here. Again, you don't have to do it by hand, but it is nice to know that you can, especially for the linear. For the quadratic, maybe not necessarily as important. But I'll show you what to do to get this on your calculator. So, if you've got your graphics calculator, Casio like we use at our school, you're going to go into your main run menu, and I want you to go into number 2, which is Stat. So you go into your Stat menu, and here you're going to see List 1 and List 2, hopefully, and you should be aiming for a table-y type thing. If you come in and you don't see a table, just hit Exit until you get backwards to where you see a table. So, to clear out what's already in your graphics calculator, you can just hit the delete button over and over again. You also have the option of hitting delete all, and it will delete everything down one column, and then delete all again will delete everything down the other column. But again, your delete button works just as well, and you can just type over them if you want as well. So when you see this table, you're going to literally plug in exactly what your table is into that graph. So you're going to put all your x information, in this case the first column, 1, 2, 3, 4, 5, into your list 1, and then list 2 is going to be all your y information, 3, 5, 7, 9. So just entering them in, hit the blue execute button after each number, and then your y values would be 3, 5, 7, 9, and 11. Now for a linear pattern, you would only need to do this, you only need 2 points, but if you think about putting in 3 every time, you'll be a lot safer as well, just to make sure that you've got it right. So there's a few things I want you to be aware of. When you are using your calculator, you still have to decide whether or not it's linear or quadratic or anything else. So you still need to calculate your first difference by hand and make sure that it is constant. But once you've got your table put in, first button you're going to push is going to be graph, GRPH there, so F1. Then you'll hit graph 1 again, so GPH1. And now stop for a minute and look at your points. That's what your table is telling you. So it looks similar to what we plotted, and you can see that you could draw a straight line through all of those, so that's another hint for you that it should be a linear pattern. So pay attention to that. Sometimes it's a good place to dummy check. If you entered in a point wrong, you'll see it standing out kind of like a sore thumb. It won't be in line with everything else, and you'll know you've entered some point in wrong. So the next button then is calc. And here you've got to choose what kind of equation you'd like to calculate. And we would like to pick x, because x is for our linear equation. We use just one single x when we're writing linear equations, as in y equals mx plus c. And we can see it's that straight line, so we'll hit the x, which is under F2. Now on your calculators, you'll have one more step here, and it will give you 2 options. One says AXB, just like you see there on the screen, and the other option says BX or ABX or something like that. Just hit F1 one more time, and you'll get to a screen that looks like this. So again, going backwards from the start, I've entered in the numbers from my table. I hit graph 1, I check to see if it's linear there, I hit calc, I hit my x variable because it is a linear equation. On your calculator you'll have to hit F1 one more time, and then you'll see this screen here. Now what we've got is our equation, and you can see that it gives you it in the form of y equals ax plus b. So we would need to just do some substitution. If you look and see a is equal to 2, well, instead of writing a, we would write 2. So 2x plus, and instead of writing b, we would write 1. So 2x plus 1, very similar to our 2p plus 1. Another thing I want you to pay attention to right now before I move on is that r squared value is equal to 1. That's really important for these equations. If you have a really long drawn out decimal there, it means you've probably put a point in incorrectly. And I can show you that really quickly. If I change this one to 10, it should come up as an error. So instead of 11, which is what I'm supposed to have, I'm going to put in 10. And you can see there, again, that's why I'm saying look at your graph. You can see there that point looks a little bit low, but if you didn't notice it there, going on to calc, hit X, you'll have one more button to push, and do you see all these big decimals in here? That's telling me that this is not a perfect equation, that this is the best it can do with the points that I've given it, but there's something that's not quite right there, meaning there's one that doesn't fit on the line, so they have to change the equation slightly to try to accommodate for all the points. So if you get decimals instead of a 1 for r squared, if you've got the newest calculator, you need to go back and look at your points really carefully and see what you've done wrong. So fix that up again. So what we can do here is, again, paying attention to what we've got on our equation. So I would want to write out y is equal to 2 for a, so 2x plus 1. So here I could say, using my calculator, y is equal to 2x plus 1, and then you need to put it into context. So don't leave it as x and y. Notice that you've got a p and an n, so replace your y and your x with p and n. So my y is actually n, so I would say n is equal to 2p, because x is p, plus 1. So that's how you get the same rule out of your calculator. So you can write down a note for that for yourself if you want, and I'll show you how to get these bits too. So, so if you needed to see those steps written down for getting the rule, I've just put them in here. Stat, enter your new table, you're going to hit F1, 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 F2 if it's linear for x, F1 again, and then you should be able to get your rule out of there using substitution. So what I want to look at here is how we might use the rule. So if we exit back to our main menu, powerful tool for this is going to be table. So again, you have to show your substitution to get full credit for these, but if you're not a fan of algebra, or if you just want to use this to help you get through it in case you're making mistakes or wanting to double check things, make sure that you are showing the substitution, and then let's use table. So table, what I want you to do is enter in the rule. So it already says y1, so that's basically like it's already got the y equals for you. So you just enter in the last part of it, 2p plus 1. Now, every single time, instead of entering a p or a q or an a or a b or an x or whatever it is, I just want you to use the variable button on your calculator, which is this one here, which you can see under under the alpha. So under the red button, you see x ot or x theta t. That's the button you'll use every single time. So if we're going to enter in that rule, which is n is equal to 2p plus 1, remember that's kind of the same thing as y is equal to 2x plus 1. We are going to enter that as, so you can see it, 2x plus 1. Now I can tell you repeatedly, lots of students will try to do this instead. They will go 2x using that x plus 1, and can you see those two x's look slightly different? One's got a slightly bold character, and if you got it by using the F5 button here, it's going to totally screw you up. The calculator loves to make you think you've done the right thing and then freak you out, so don't do that. It will give you a massive error, and you won't be happy. So use the button under the red one, that x theta t, every single time. I have to do this again. 2x plus 1. Done. Okay. Now you can go into table using the F6 button, and it's just going to give you all the ordered pairs that you possibly could ever need, right? But it ends at 5, depending on the default, which isn't very helpful for us if we need the 10th pattern. So let's exit backwards. And I want you to go to set. On set, we can tell this calculator where we want it to start and where we want it to end. So right now it's only going to go for the first 5 patterns, 1 to 5. Let's make that the first, I don't know, 20 patterns. See what happens. And my step of 1 means I'm going to go from pattern 1 to 2 to 3 to 4. If you just wanted to do every 5th pattern, you could go a step of 5, and it would go 1, 5, 10, 15, etc. So go to table again, and if you scroll down now, you can see I've got all the way up to 20 in there. So this can be helpful if you're just trying to look around for solutions. The table basically just keeps to making more and more output for you using your rule. But if you needed to know how many matchsticks for the 10th pattern, well, the 10th pattern is the x column, so we could scroll down to number 10, and you can see it's pair there, the y, will be 21, which is what we found using our algebra as well. For the 10th pattern, we need 21 matchsticks. The next question was asking us if we had 29 matchsticks, what pattern did I make? So let's scroll through the matchsticks column, and we can see we've got 29 matchsticks at the 14th pattern. So again, that will give you your answers without having to use the algebra, but you do have to show your substitution. There are other ways as well to get these answers, but table's probably the most straightforward one. We can also use graph and your equation solver as well, but the table is a pretty helpful tool here for you. So again, you can scroll through and look for y values, or you can scroll through and look for x values. And an important thing there that I did is that I went into set to tell it where to start and where to finish. So for instance, I know if I'm looking for, like, I don't know, a couple hundred matchsticks, maybe I'd start at the 60th pattern and go to the 100th pattern. And if I get into my table now, see I'm starting at pattern 60, and I could go all the way to 100, so I could scroll through and look to see, you know, what pattern number might have close to 150 matchsticks, and I can see in this case that would be 75 or 74, but I can't have exactly 150 matchsticks in that pattern. So you can use that for troubleshooting and problem-solving questions to kind of get you where you want to go, but make sure you remember that set is where you change your start and your end. And again, to show this one, if I did a step of 5, it's just going to show me every fifth one. So in this case, 1 plus 5 is 6, plus 5 is 11, plus 5 will get you to 16, and you can see here that I'm just going to every fifth pattern. So set here. On the older green calculators, it'll say range, but not many of you guys have that. So again, 20, whatever that you need the numbers to be. But be aware of that. People often forget you can adjust it using that. So that's a good skill. Again, that's in table, and make sure you always use the button under the red one there, the XOT, when you're typing things out. Right.